Okay, so let's try to go for some more problem for variational principle. Okay, so this problem is very interesting. So Vx is equal to infinity if x is less than 0 and kx if x is greater than 0. So this is my potential, and we have to take a trial wave function that psi t is equal to a x e to the power minus alpha x. Obviously, between 0 to infinity and 0 otherwise. So obviously, suppose this is your wave function or this is your trial wave function. You can have this one. And we have to use the variational method, and we have to just find the energy for minimum value of energy. So in this problem, obviously we have to calculate each and everything. So why I have chosen this one? Because we have to also practice sometimes about the calculating the kinetic energy also. But before that, we have to also calculate the value of A such that my psi x is normalized. So in this problem, we will solve each and everything. Okay. Earlier, we have just taken the very famous wave function such as Gaussian or the sine function. So we know the solution or we know the expectation value of kinetic energy for the very popular wave function. But this is not very popular wave function. So sometime you can have this one. And I will also give you the trick how to solve this type of problem. So let's try to go step by step to each to solve this thing completely. So first I have to go for normalization condition. So mod psi t square dx, obviously from minus infinity to plus infinity must be equal to 1. And from here we have mod a square 0 to infinity, because this function is defined between 0 to infinity, otherwise it is 0. So this is x square e to the power minus 2 alpha x dx must be equal to 1. We can easily use gamma integral. And when we are going to use gamma integral, then we have 1 upon 2 alpha cube and gamma 3 must be equal to 1. And we can have this particular value so that I can use this space. Okay. So from here, we can have a square 1 upon 2 alpha cube, and that gamma 3 is nothing but factorial 2. That value is 2. So we have a is equal to 4 alpha cube to the power 1 by 2. So you can write 2 to the power alpha 2 into alpha 3 by 2 to the power 3 by 2 also. But I am writing in this way. It's up to you that how you can write it. Now, the first thing we have calculated the value of A. Now we have to calculate the value of kinetic energy. So let's try to calculate the value of kinetic energy. So when we will calculate the value of kinetic energy, then we have to go from minus infinity to plus infinity. Psi t star and the kinetic energy operator is, and we have to go for t dx. And what is my kinetic energy operator is minus h cut square upon 2m d square upon dx square. So we have to calculate first this particular thing d square upon dx square on this particular state psi. And then we will put it into this equation and we can again use the gamma integral and we can solve it. So let's try to see how we can find the kinetic energy and how we can compact our calculation and how we can do the calculation very fastly. So let's try to go for this. This is very interesting. So if I am talking about that t psi t, and this psi t is basically the trial wave function, then we have to just go for minus h cut square upon 2m d square psi t upon dx square. So we have to go for the second order derivative for this particular wave function. So when we will go for second order derivative, right now I am just ignoring this particular 4 alpha cube to the power half because I have to just go for this one. So let's try to go for, if psi is equal to something x e to the power minus alpha x, I will put the value of a into this particular integration such that I can use the enough space for the important calculation. Okay. Then when we will go for d psi upon dx, then this value is e to the power minus alpha x minus x alpha e to the power minus alpha x. Isn't it? यहाँ तक clear है ना? And when you will go for next level of differentiation, so you have to be very much careful. Don't do it blindly. Whenever you have exponential function, sine function, cos function, this type of function will be there. You can use this calculation into this one. Look at how we can use. So if we are going to this one, then this is nothing d upon dx, d psi upon dx. Okay. So when we are going to calculate this one, so this value is equal to minus alpha e to the power minus alpha x. So I have differentiating this one, and minus, I can put alpha here, and you can see d upon dx, x e to the power minus alpha x. So what you have already calculated this one, isn't it? दिखाई दे रहा है क्या?
Yes, sir.
ये पार्ट हम, तो जब भी आपके साइन फंक्शन हो, कॉस फंक्शन हो, या फिर एक्सपोनेंशियल फंक्शन हो, यू कैन यूज ट्रिक. सो बहुत ही आप बिल्कुल ही फोकस होकर के ये कैलकुलेशन करना, अदरवाइज इट विल बिकम वेरी लेंथी. ओके, सो नाउ आई कैन डायरेक्टली पुट दिस वैल्यू. सो व्हाट विल हैपन? So this value is equal to minus alpha e to the power minus alpha x minus alpha, and here I can put e to the power minus alpha x minus alpha x e to the power minus alpha x. That's it. And then we have minus alpha e to the power minus alpha x minus alpha e to the power minus alpha x plus alpha square x e to the power minus alpha x. And now this value is equal to alpha square x e to the power minus alpha x minus 2 alpha e to the power minus alpha x. So this is our second order derivative. देख रहे हो कितना फास्ट हो गया है ना? एंड आपके गलती होने के भी चांस काफी कम हो जाएंगे. नाउ लेट्स ट्राई टू कैलकुलेट द average value of kinetic energy. So the average value of kinetic energy, now this value is minus h cut square upon 2m minus infinity to plus infinity psi star t, or you can just write t square psi t upon dx square dx. We have calculated this particular thing with ourselves, and we can put it this particular value. So minus h cut square upon 2m, and here we have 4 alpha cube is there due to normalization, this one, and from there we have half will be gone, and we have basically from 0 to infinity, because my wave function is from 0 to infinity, and this value is e to the power minus alpha x, and this thing we can write it from here. So that value is equal to alpha square x e to the power minus alpha x minus 2 alpha e to the power minus alpha x. So we can just go for two basic integration. So let's try to do it. So minus h cut square upon 2m 4 alpha square, and we have first integration is 0 to infinity, that is alpha square x e to the power minus 2 alpha x, and second integration is 0 to infinity, we have 2 alpha e to the power minus 2 alpha x. सही किया हूं?
There
Yes?
was X also.
Sorry?
X also there was the psi t star.
क्या x also? ये तो है x.
पर ऊपर वाले में सर फिर ऊपर वाले
हाँ,
स्टेप
sorry. Good. Thank you. So there is x square and there is good, very good. 2 alpha x is also there. Good. Very good. Otherwise तो बहुत ब्लंडर आने वाला था. देख रहे हो किस तरह की गलतियां हो जाती है. Okay, good. Now we have to just go for this one. So minus h cut square upon 2m 4 alpha cube actually. 4 alpha cube. And what will be this integral? Alpha square 1 upon 2 alpha to the power. क्या हो जाएगा ये? क्यूब फैक्टोरियल 2 है ना, माइनस 2 अल्फा 1 अपॉन 2 अल्फा स्क्वायर फैक्टोरियल 1. ठीक है, सही है ये,
यस सर।
है ना? क्या आ रहा है वैल्यू, जरा कैलकुलेट करके बताओ. पॉजिटिव आनी चाहिए, है ना? सो आई थिंक दिस वैल्यू मस्ट बी अल्फा स्क्वायर एच कट स्क्वायर बाई 2m आ रहा है. जस्ट चेक इट फास्टली चेक करो. So alpha square is there, 2 is there, so 4 is there, okay, and minus we have 2 alpha is there, so that will be 4 is there and minus 2 will be there, so 4 and 4 will cancel. So I think this is the correct answer. सही आ रहा है क्या? Just check it. check it fast. आ रहा है ये, देख लो ना. This is 8, isn't it? And 2, that will be 4 is there, and you have alpha is there, so 1 upon 4 alpha minus, and what you will have here, 4 alpha square, alpha is cancel, so 2 alpha, so minus is there, 1 by 4 minus 1 by 2, and alpha square will be there because 1 alpha is gone, and 4 and 4 will cancel, so this will be answer, isn't it? Okay, so we have calculated already this particular kinetic energy. Now we have to go for calculating the potential energy. So let's try to go for calculating the potential. So now you can see how much time it will take if you have to calculate each and everything. And lot of calculation is there, isn't it? So अभी तो हमने problem शुरू भी नहीं किया है. So we have calculated kinetic energy. The kinetic energy is equal to alpha square h cut square upon 2m. Now let's calculate the potential energy. The potential energy is nothing but minus infinity to plus infinity psi star t potential energy psi t dx. And when you will go for this, you have again 4 alpha cube and we have x square e to the power minus 2 alpha x into 1x for the potential, that is x cube dx 0 to infinity. सही है? And k is also there. So 1 k is also there because in the potential energy you have k there. So you have 4 alpha cube k, and what is this integration? 1 upon 2 alpha to the power 4 and factorial 3. सही है ये everyone? And then try to calculate this one. So here is 4 upon 16, isn't it? 4 upon 16, 1 upon alpha, that is factorial 3 is 3 into 2 into k. So 4 and 4, 2 and 2. So we have 3 upon 2 k by alpha. आ रहा है क्या? Just check it.
Yes, sir.
आ रहा है ना? Because once I think that will be the correct value of potential energy. Okay. Okay. So now let's try to go for using the variational principle. So now we have what we have? We have expectation value of energy. The expectation value of energy is alpha square h cut square upon 2m plus 3 by 2 k by alpha. Now we have to go for what is parameter here? भूल मत जाना. किसके साथ डिफरेंशिएट करें? अल्फा के साथ. Okay. So this is your dE upon d alpha. So we have 2 alpha h cut square upon 2m minus 3 by 2 k upon alpha square is equal to 0. Now next step बताओ क्या करना होगा? What we have to do for the next step?
सर एनर्जी को
एनर्जी को पोटेंशियल
काइनेटिक एनर्जी को पोटेंशियल एनर्जी के टर्म में लिखेंगे, है ना? So we have 2 alpha h cut square upon 2m must be 3 by 2 k by alpha square. अल्फा से यहां मल्टीप्लाई कर दें, अल्फा से यहां भी मल्टीप्लाई कर दें, 2 से डिवाइड कर दें, 2 से डिवाइड कर दें, है ना? So you have kinetic energy is equal to 3 by 2, sorry, 3 by 4 k upon alpha, है ना? So this is your kinetic energy. So your total energy E is equal to 3 by 4 k by alpha plus 3 by 2 k by alpha. ये वैल्यू कितना हो जाएगा? So 9 by 4 k by alpha. ठीक है? So now we have to calculate the value of alpha now, है ना? So you have to calculate value of alpha. So from where we can calculate the value of alpha? From itself there. और 1 by alpha या alpha की value किसी की value निकाल लो. So we can easily calculate the value of alpha. So what is the value of alpha here? इसे calculate कर सकते हो? So you have alpha h cut square upon m must be equal to 3 by 2 k upon alpha square. So your alpha cube is equal to 3 by 2 mk upon h cut square. Now we can put the value and we can get the final solution. देख रहे हो कितना लंबा कैलकुलेशन हो जाता है ना? So average value of energy is equal to, we can have 4 upon 9 into k and 1 upon alpha. We can have basically the value of alpha is equal to 2h. So you can write 2h cut square upon 3 mk to the power 1 by 3. So now you can adjust with yourself. जैसे भी फाइनल सॉल्यूशन फाइनल आंसर दिया रहेगा जिस फॉर्म में, उस फॉर्म में आप सारे चीज को एडजस्ट कर सकते हो. So you can see it will take, if you are going to calculate each and everything, it will take at least 10 to 15 minutes to solving one problem. So in the examination, you have to attempt this problem very intelligently. Otherwise, it will take lot of time. ठीक है? So let's try to go for one more problem. Clear है ये?
9/4 आंसर. 9/4.
अच्छा 9/4 ठीक है. गुड. 9/4. 9/4 वेरी गुड. चलो. So अब आप इसको अपने ढंग से देख लेना. अंदर इसको लेकर के जाओ तो 9 क्यूब हो जाएगा. इसको लेकर के जाओ तो 4 क्यूब हो जाएगा. k को अंदर लेके जाओ तो k क्यूब हो जाएगा. एंड यू कैन राइट द आंसर इन अ वेरी कॉम्पैक्ट फॉर्म. ओके. चलो. So let's try to go for one more problem. So I have a trial wave function, and that trial wave function is a x square minus a square, or I think a square minus x square. Let me check. Sorry, this is a square minus x square. Okay. So that value is a square minus x square, where x is between minus a2 plus a and 0 otherwise. So what you have to do, you have to use the variational method and find the energy for harmonic oscillator. Suppose this is trial wave function for harmonic oscillator. Okay. So obviously we can easily calculate the average value of kinetic energy. First we have to calculate the value of A. So what is value of A? What is, ये मैंने लिखवाया था लास्ट क्लास में, बताइए क्या होगा वैल्यू ऑफ A?
Root under 15 by 16.
15 by 16 A cube. Sorry, a to the power 5, not a cube. A to the power 5 to the power half a square minus x square. Okay. And what will be kinetic energy? लिखवाया था last class में. What is that?
5 by 4.
Very good. 5 by 4. क्या था ये?
H cut square.
H cut square by ms
square.
Okay. तो obviously अगर आप ये याद नहीं किए रहोगे तो आपको फिर से कैलकुलेट करना होगा, है ना? तो यू हैव टू जस्ट गो फॉर सेकंड ऑर्डर डेरिवेटिव. तो जब सेकंड ऑर्डर डेरिवेटिव में जाओगे तो ये तो बहुत आसान हो जाएगा. एक्स स्क्वायर दोनों ही खत्म हो जाएगा, ओनली 2 विल बी देयर, है ना? सो यू हैव टू जस्ट टेक psi t and multiply with 2 and integrate from minus a to plus a. So I am just leaving on to you that you can calculate this one. So let's try to go for average value of potential energy. ये तो आपको निकालना ही पड़ेगा, इससे आप बच के नहीं रह सकते हो, है ना? So you have to go for average value of potential energy. So that value is equal to obviously minus infinity to plus infinity psi star t vx psi t dx. And you have half m omega square x square. कहां से कहां जाएंगे? Minus a to plus a. And you have, sorry, m omega square बाहर ले लें. And you have 15 upon 16 a to the power 5, and inside you have x square a square minus x square dx. Now the calculation is very easy, but there is very fair chance that you can do some blunder, some error into calculation. So why we can just check whether which type of function is there. Whenever you see this type of function, this type of limit, then first you have to check whether they are any chance to get odd function or even function or not. So yes, if I will change x to minus x, this will be what? Even function. So I can go for half m omega square 15 upon 16 a to the power 5 into, sorry, niche, a to the power 5 2 times 0 to a x square, and this is a square also because psi star psi is there. So x square a square minus x square whole square dx. So this 2 and this 2 is cancel out. And when you will go for the calculation, that is m omega square, and that is 15 upon 16 a to the power 5. And this calculation is between 0 to a, and we have x to the power 4 a square, है ना? देख लो, a square plus b square minus 2ab plus सेकंड वाला क्या हो जाएगा? x to the power 6 minus 2 times x to the power, sorry, this is x square actually. This is a4 x square, a4 x square. And this will be 2 into x square into x square dx. सही है ना? जस्ट चेक इट. ओपन करके एक्स स्क्वायर से मल्टीप्लाई कर रहा है.
ए स्क्वायर भी आएगा
हम्म?
लास्ट वाले टर्म में ए
ए
स्क्वायर
स्क्वायर भी आएगा, ऑब्वियसली ए स्क्वायर भी आएगा, ठीक है। ओके, सो 15/16 m ओमेगा स्क्वायर a5। अब देखो यहां जीरो करने का फायदा ये हुआ कि सिर्फ हमें ए का ही वैल्यू पुट करना होगा, ठीक है। सो द फर्स्ट टर्म जरा आप चेक करना, फर्स्ट टर्म विल बी a7, यहाँ 4 है, इंटीग्रेट करेंगे तो सब में 7 तो होना ही होना है, तो a7 बाई क्यूब। सेकेंड इज a7 बाई 7। थर्ड इज you have 2 टाइम a7 बाई 5। हो रहा है क्या? अगर आप यहां पर माइनस रहने दोगे फिर इंटीग्रेट करोगे, इट विल बी वेरी क्लमजी, बहुत ही ज्यादा क्लमजी हो जाएगा। देखो सही किया हूं?
Yes, sir.
यस, एंड देन दिस वैल्यू इज इक्वल टू 15/16 m ओमेगा स्क्वायर अपॉन a5। so you have a7, you can take common, you have 35 plus 15 minus 42 by 3 into 7 into 5. So this value is equal to what? 60 minus, that value is 8, isn't it? Sorry, 50 minus 42 is 8. So I am using this space. So 15/16 m omega square a7 by a5 into, that value is 8 by 3 into 7 into 5. So what will happen? 5, 3, 3, 3, 8, 2, and you have m omega square a square by 14. आ रहा है क्या?
Yes, sir.
Yes, sir.
है ना? So this is your average value of potential energy. So you can see. So देख रहे हो, कैलकुलेशन इज वेरी इंटरेस्टिंग। और मैं ये आज की क्लास सिर्फ इसलिए आपके साथ ले रहा हूं कि आप इसमें कॉन्सेप्ट तो बिल्कुल सिंपल है, बट कैलकुलेशन देखो आपको कितना स्मार्टली करना पड़ रहा है। सो यू हैव टू जस्ट डू दिस टाइप ऑफ कैलकुलेशन, और इसकी बहुत प्रैक्टिस की जरूरत है ना। सो नाउ वी हैव एवरेज वैल्यू ऑफ काइनेटिक एनर्जी। व्हाट इज एवरेज वैल्यू ऑफ काइनेटिक एनर्जी? 5/4 h कैट स्क्वायर अपॉन ma स्क्वायर। इसको तो अभी हमने कैलकुलेट पहले से करके रखा हुआ है। एंड व्हाट इज एवरेज वैल्यू ऑफ पोटेंशियल एनर्जी? m ओमेगा स्क्वायर a स्क्वायर अपॉन 14। सही है ना? ओके, सो व्हाट इज योर एवरेज वैल्यू ऑफ एनर्जी इज इक्वल टू 5/4 h कैट स्क्वायर ma स्क्वायर प्लस m omega square a square by 14. So you will go for del E upon del A, and that value is equal to, यहाँ क्या हो जाएगा? 2 into 5/4 h cut square ma cube, and here that value is equal to plus m omega square 2a by 14 must be equal to 0. So first what we have to do, we have to write kinetic energy in term of potential energy, है ना? So इसके लिए लिख सकते हैं 2 into 5/4 h cut square ma cube must be equal to m omega square 2a by 14. So what we have to do, we have to multiply with a, we have to multiply with a, we have to divide with 2, we have to divide with 2. So we have kinetic energy, and this kinetic energy is equivalent to what? M omega square a square by 14. So exactly average value of kinetic energy and average value of potential energy is same. And more or less you know this particular thing, information about the harmonic oscillator. If you have even function, you can have the average value of kinetic energy equal to average value of potential energy. So you have m omega square a square by 14 plus m omega square a square by 14. And what will be this value? So that is your m omega square by 7 a square. And now you have to calculate the value of a square actually. So from here we can calculate the value of a square. या फिर a की वैल्यू कैलकुलेट कर लेंगे, बाकी सारा अपने आप मिल जाएगा. So let's try to calculate it. क्या आ रहा है वैल्यू? So you have minus 5 upon 2 h cut square by m a cube is equal to m omega square 7a. So I can take a cube here, so that will be a to the power 4 is equal to 35 by 2, and you have h cut square by m square omega square. सही है ना? So what is a square? A square is 35 by 2 h cut square m square omega square. ठीक क्या या गड़बड़ है कुछ? देख लो जरा. A square to the power half actually. Okay. So you can put the value that is m omega square, and you have 1 by 7 into h cut upon m omega, and you have root under 35 by 2. So you have obviously dimension must be as a h cut omega, and inside bracket we have 35 by 49 into 2. So what will be answer? Five upon 14 है ना? 5 upon 14 h cut omega. So this will be your answer. Clear है? Yes या no? You are not responding. क्या हो गया?
Yes, sir.
देखो कैलकुलेशन तो क्वांटम मैकेनिक्स का सोल है, इससे आप नहीं भाग सकते हो, है ना? सो डोंट गेट फियर्ड, है ना? डरने की जरूरत नहीं है. यू हैव टू डिग योर माइंड इनटू कैलकुलेशन, एंड ये क्वेश्चन आपके एग्जाम में भी आ चुका है. ओके, सो प्लीज प्रैक्टिस इट. इसीलिए मैंने आपको कहा था कि आप ट्यूटोरियल करके रखना. किया था आप लोगों ने? नहीं
Yes,
है
sir.
ना? किया था तो उसमें से प्रॉब्लम था ये
Yes, sir.
या
Net
पीवाईक्यू में था,
PYQ में आया.
है ना? ओके, नाउ लेट्स गो फॉर लास्ट वन. एक और करते हैं, फिर कल की क्लास में हम लोग डब्ल्यू के भी अप्रोक्सीमेशन देखेंगे. ओके, चलो. So let's go for potential for hydrogen atom is minus k by r, where k you know that is e square by 4 pi epsilon naught. And what is your trial wave function? Your trial wave function is a e to the power minus alpha r square, where r is between 0 to infinity. Now, what should be value of r here? Sorry, value of a here. And this is into a spherical polar coordinate. What is value of a here?
2
Anyone?
alpha. 2
Huh?
alpha by pi.
हाँ वेरी गुड, क्या होगा बताओ?
2 alpha by pi whole
2
to the
अल्फा बाई पाई
whole to the power 3 by 4.
3 बाई 2, सोच करके
3 by 4.
3 by 4, very good, very good. 3 by 4 e to the power minus alpha r square, where r is between 0 to infinity. 3 by alpha by 4 क्यों? Because this is into polar coordinate, है ना? This is into a spherical polar coordinate. और r स्क्वायर को क्या लिख सकते हो आप? x स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर. आर यू गेटिंग माई पॉइंट? सो x वाले के लिए क्या था आपका नॉर्मलाइजेशन
1 by
कांस्टेंट?
4.
2 अल्फा बाई पाई टू द पावर 1 बाई 4. उसी तरह से y का होगा, उसी तरह से z का होगा. यू कैन गेट दिस वन. नाउ यू कैन जस्ट टेल मी व्हाट विल बी योर काइनेटिक एनर्जी? वेरी गुड, वेरी गुड. व्हाट विल बी योर काइनेटिक एनर्जी हियर?
3 by 2 h square alpha
Very
by
good. 3 by 2 h cut square alpha by 2m. वन डायमेंशनल हार्मोनिक और वन डायमेंशन गॉसियन के लिए आपको पता था क्या था? वन डायमेंशन के लिए h कट स्क्वायर अल्फा बाई 2m, है ना? दिस इज फॉर वन डायमेंशन. सो आपका जब 3 डायमेंशन हो रहा है तो देन व्हाट विल हैपन? देन अनदर 2 डायमेंशन विल बी एडेड, बिकॉज दिस इज योर सिमेट्रिक पोटेंशियल. जो x के लिए होगा वही y के लिए होगा, वही z के लिए होगा. सो दैट विल बी 3 h कट स्क्वायर अल्फा बाई 2m. नाउ वी हैव टू गो फॉर फाइंडिंग द potential energy. So when we are going for the finding of potential energy, what should be my integration? Integration क्या होगा बताइए? Obviously you will go from 0 to infinity psi star Vr psi r square dr, और किससे मल्टीप्लाई करना होगा? We have to multiply with 4 pi, because sin theta d theta d phi, that will be also part of your integration. Hence this wave function is not a function of theta. This is basically the ground state is radially symmetric for L is equal to 0, है ना? इसी कारण हम 4 पाई को डायरेक्ट बाहर ले जा सकते हैं. अदरवाइज यू हैव टू जस्ट गो फॉर दिस इंटीग्रेशन d क्यूब r. जब d क्यूब r के लिए जाओगे तो साइन थीटा d थीटा भी आपका रहेगा पार्ट, इंटीग्रेशन का पार्ट. देन यू विल गेट दिस वन. आर यू गेटिंग माई पॉइंट? बिकॉज x की वैल्यू कहां से कहां जा रही है? माइनस इंफिनिटी टू प्लस इंफिनिटी. y इज गोइंग फ्रॉम माइनस इंफिनिटी टू प्लस इंफिनिटी. z इज ऑल्सो गोइंग फ्रॉम माइनस इंफिनिटी टू प्लस इंफिनिटी. व्हाट इज मीनिंग ऑफ दैट? Meaning of that, r is going 0 to infinity and theta is going 0 to pi and phi is going 0 to 2 pi. So you have to go for all particular integration. Are everybody is clear here? Is हर एक कोई समझ में आ रहा है आपको?
yes sir.
Okay. So why when you are going to integrate this one, then what you will get? 4 pi is there, integration, and 4 pi is there. You have 2 alpha by pi to the power 3 by 2. 3 by 2 क्यों? Psi star और psi दोनों के लिए. And what is your potential? Minus k will be there. 1 by r is there. E to the power minus 2 alpha r square dr. And you will go from 0 to infinity. And now we can integrate it by gamma integral. 2 alpha upon pi to the power 3 by 2 minus k, and there is r, 1 by r is there. So क्या हो जाएगा ये इंटीग्रेशन? 1 upon 2 alpha to the power 3 by 2, and half will be also there, and gamma 3 by 2. Everyone is comfortable?
Yes, sir.
है ना? So what you have? You have 4 pi 2 alpha upon pi, and minus k is there, 1 upon 2 alpha to the power 3 by 2, और ये वैल्यू क्या हो जाएगा? हाफ रूट पाई. So and this is also 3 by 2. So this 3 by 2 and this will be cancel out. अल्फा सारा कैंसिल हो जा रहा है. माय गुडनेस, कुछ गड़बड़ होगा.
सर 1/r और r² था ना, तो एक r कट जाएगा,
हाँ,
तो फिर 2α 3/2 नहीं आएगा ना सर,
2 अल्फा 1/2 आएगा ना।
2 आएगा।
दैट इज नो, 1 कैसे आएगा? एक आर कैंसिल हो गया, सो r⁻1, सो 1 प्लस, सॉरी कुछ यहाँ पे गड़बड़ हो रहा है, जस्ट मिनट। सो वी हैव 4 पाई 2 अल्फा अपॉन पाई टू द पावर 3/2 माइनस के इंटू, यहां पर क्या आएगा 1 अपॉन 2 अल्फा 1 प्लस 1/2, 1 प्लस 1/2 ये होगा ना। यस, एंड यू हैव गामा 1 प्लस 1/2, दिस विल बी देयर। आर यू एग्रीड?
यस सर।
क्योंकि हम क्या इंटीग्रेशन यूज कर रहे हैं, वी आर इंटीग्रेट यूजिंग x टू द पावर n e टू द पावर माइनस अल्फा एक्स स्क्वायर, दैट इज 1/2 1 अपॉन अल्फा n प्लस 1/2 गामा n प्लस 1/2। सॉरी, लास्ट पार्ट में हमने थोड़ी सी गलती की थी। ओके,
upper part of that value
1/2 और आएगा ना एक।
एक और 1/2 आएगा। यस, एक और 1/2 आएगा। वेरी गुड।
but that
So-
is not visible which you have written upside.
अच्छा, जो ऊपर में लिखा है नहीं दिखाई दे रहा है, फॉर्मूला लिखा है, ठीक है ये। यस, सो नाउ लेट्स सी व्हाट इज गोइंग टू हैपन। 4 पाई, अब क्या बचेगा हमारे पास? सो दैट इज 1 एंड यू विल गेट व्हाट 2 अल्फा टू द पावर हाफ, है ना। यू विल गेट 2 अल्फा टू द पावर हाफ minus k is there and pi to the power half and pi to the power 3/2 and 1/2, and this will be gamma 1. So gamma 1 is 1. So this will be 2 pi. Okay. So ठीक लिखा हूं इसे? So you have, and you have 1 pi and 1 pi is also there. So what you will have? 2 alpha upon
Root
pi to the power half यहाँ भी होगा, है ना?
Yes, sir.
So that will be 1/2 and you have minus 2k is there, बाहर में minus 2k। क्लियर है ये? तो दिस इज योर पोटेंशियल एनर्जी, अगर मैं गलत नहीं हूं तो। चेक कर लो सही है गलत है।
सही है सर ये।
सही है पक्का?
Yes, sir.
ओके, चलो। सो वी हैव गेट आवर पोटेंशियल एनर्जी, नाउ वी कैन यूज आवर बेसिकली टोटल एनर्जी ऑफ अ सिस्टम। सो देख रहे हो किस तरह का कैलकुलेशन है। सो एवरेज वैल्यू ऑफ एनर्जी इज इक्वल टू काइनेटिक एनर्जी प्लस पोटेंशियल एनर्जी। सो काइनेटिक एनर्जी अभी हमारा क्या आया था, 3h² अल्फा अपॉन 2m and this will be minus 2 and you have 2 to the power half and ऐसे लिख देते 2/pi to the power half and k alpha to the power half। ठीक है? And now we have to go for del E upon del alpha and that value is equal to 0. So you have 3h² upon 2m minus 2 upon pi to the power half k 1/2 alpha to the power minus half। ठीक है ना? Now this must be equal to what? 0. So when this will be equal to 0, first thing what we have to do, we have to write kinetic energy in term of potential energy. So we have 3h² I can multiply with, or you can write something like this, by 2m is equal to 2 by pi to the power half k, and sorry, 1 by 2 and alpha to the power minus half. Just a minute. दिखाई दे रहा है अब किससे मल्टीप्लाई करें? यहां से अल्फा से मल्टीप्लाई करें, यहां भी अल्फा से मल्टीप्लाई करेंगे. Then we have kinetic energy, and that kinetic energy is equal to the average of kinetic energy. क्या मिल रहा है आपका?
K root alpha
2 by pi to the power half k root alpha, है ना? And when you will put it here, the average value of energy is equal to minus 2 upon pi to the power half k root alpha. सही है ना? And now we have to find value of root alpha from here. So इस इक्वेशन से आप क्या कर लोगे? रूट अल्फा की वैल्यू निकाल सकते हो. So just try to use this equation, है ना? इस इक्वेशन से इजिली रूट अल्फा की वैल्यू निकाल सकते हैं. What will be alpha to the power half? इसको इधर ले गए, alpha to the power half, this and this will cancel, and you have 2m upon 3 h cut square into 2 by pi to the power half into k. So this is your alpha to the power half. You can put it this particular value and put the value of k with the e square by 4 pi epsilon naught. You can get exactly more or less same dimension. Okay. So this value is minus 2 upon pi to the power 1 by 2 k. And what is your root alpha? 2m upon 3 h cut square 2 by pi to the power half into k. So this is your average value of energy. Yes, it should be negative because आप देख पा रहे हो, और यहाँ पर आप पुट करो k की वैल्यू और इसको जितना चाहो उतना कॉम्पैक्ट कर सकते हो. So now you can see, मैं जानबूझ करके ये सारे प्रॉब्लम आपके सामने कर रहा हूं बिकॉज आपको कैलकुलेशन की वैल्यू पता चले. इन जनरल होता क्या है, इन सारे टॉपिक को हम ऐसे ही छोड़ देते हैं कि चलो हम तो समझ गए, काइनेटिक एनर्जी निकालेंगे, पोटेंशियल एनर्जी निकालेंगे, वहां जाकर हो जाएगा. बट लुक एट, I am doing this thing from last 15 years, but फिर भी कैलकुलेशन में समय लगता है. If you are not mugging up all the calculation, okay? So don't try to mug up calculation, but try to practice it. This is very important, especially in this particular chapter. Okay? So I think we must stop here, and tomorrow we will go for next topic, that is WKV approximation. ठीक है? Thank you.
Thank you, sir.
Thank you,
Just
sir.
you can see the final answer. Okay. It is very difficult to write each and everything into single board, mainly in quantum mechanics. Chalo. Thank you.